As a writer for Physics Today, I have created a travel vlog during an overseas trip of my European vacation. I'm going to go over physics principles that I encountered in my journey and details of how they are applied. I will go over principles of classical physics, use the scientific method in a modern physical problem, and go over a technology of quantum mechanics that is used during my experience. The scientific method is what we use to conduct experiments and generate results or theories in an organized manner. For example, while studying potential origins of nuclei that were formed via the R process, the University of Michigan observed that two specific nuclei formed from the R process, iodine-129 and curium-247, which both decay at almost the exact same rate. This meant that the ratio of these two nuclei should accurately reflect on how many neutrons were available before the solar system existed. This is because it takes more neutrons to form curium than iodine, and having more curium-247 compared to iodine-129 would mean there were more neutrons available to form the higher neutron curium-247 nuclei. When it comes to the hypothesis, we are still very uncertain of how many neutrons have existed before the solar system, so the researchers at the University of Michigan did not specifically state in an educated manner whether they thought which nuclei the meteorite would consist of more than the other. However, if they were to have a hypothesis, they would likely guess the ratio, whether high or low, without any educated reason, and just let the results suggest the amount of neutrons that have existed and how the nuclei originally formed. Both nuclei are turned into solids in the form of meteorites, so the University of Michigan tested how much certain astronomy events have contributed to the formations of these two nuclei by calculating the ratio of these two nuclei on the meteorites they have. If there is more curium-247 compared to iodine-129, thus have more neutrons available, it would be theorized that the collision between two neutron stars would have made a bigger contribution to forming these elements due to these stars being rich in neutrons. Since the ratio they calculated showed there was more iodine-129 than curium-247, they concluded that neutron stars did not make a big part in the formation of these nuclei. Having a higher amount of iodine-129 in this experiment created a theory that there were not as many neutrons available before the solar system as there would be more curium if more neutrons existed. This experiment did not confirm the origin of how these nuclei formed, but they could provide more theoretical information after it. Here's where I will go over the situations I ran into principles of classical physics. Newton's first law relates to inertia, which states that the motion of an object will not change unless another force is applied to it. Whenever I was on the plane or in a taxi to get back to my hostel, I would wear a seatbelt that would prevent me from lunging off the seat if I were to crash. The speed of the plane would change if the thrust increases or decreases, and the speed of the taxi would increase or decrease if the force applied to one of the pedals changes. His second law states that the heavier the mass of an object, the more force that must be applied to achieve the same rate of acceleration. I will make the plane or taxi heavier by going inside, but since my weight was trivial compared to the weight of both modes of transportation, there is a minimal change in force needed to achieve a certain acceleration. Also, while I was touring around Europe, Newton's third law came into my situation when I was walking, as the amount of force I put into the surface I was walking on produces an equal but opposite force on my foot that pushes me forward. Gravity is a principle that I have run into in multiple situations during my trip. First, it should be noted that lift to a plane is caused by the shape of the wing as air travels faster over it than underneath. The slower air travel underneath results in a force of lift that is stronger than the force of gravity. When it was time to descend, the plane was adjusted to where the force of gravity was stronger than the lift, causing the plane to go down. Also, one thing to know about Einstein's theory of relativity is that gravity makes time dilate, and people age faster when in a situation there is an absence of weaker form of gravity. Since I was not affected by the full force of gravity while on the plane, I have aged slightly faster than I would have if I stayed on the ground. However, this is only a difference of microseconds I would have aged, so it is a trivial difference. Light is an important principle when I want to create memories of my traveling. I used light when I wanted to take pictures or record videos of my trip on my phone camera. The way it works is that light will go through a lens in the camera, and an image sensor chip will turn the light into millions of pixels. The sensor will then measure the brightness of each of the pixels and then translate that into colors for the camera to read. Quantum physics was used with the Global Positioning System, or GPS, that is in the plane that I traveled in going to Europe and coming back home. GPS has prevented the need for the use of a map or directions from other people. However, how it works is that a three-part system that consists of satellites, ground stations, and receivers. When the plane wants to arrive at a specific location, several satellites in different locations in space will send a message to a receiver that will compute its latitude, longitude, altitude, and time. The results will show the directions to the location and how far the receiver is from the location if the plane travels at an appropriate speed. In conclusion, there are so many physics principles that have occurred within my trip, but that should not be a surprise, as it's happening within every single action that happens within the universe, no matter how trivial it is.